This principle of automatic motion has been expanded till today big industries have productions almost entirely dependent on semi-automatic machines. Let's visit one of the British Motor Corporation's huge machine shops and see the kind of equipment that is being used for the production of engine parts. The first machine of this type was installed nearly 25 years ago, and they're being developed all the time. At the head of this machine, an operator clamps a cylinder block into a fixture and pushes it into line on a roller track. From now on, the machine is automatic. Once the block is in its clutches, it is passed from station to station, while each operation is recorded by the lamps on the panel. Here, the block is passing several milling cutters, which are machining the top and bottom faces simultaneously. Look how easily the cutters remove the surplus metal, almost like slicing butter. Further along the line, the blocks stop in front of a cluster of drills which move in and, guided by the jig, do their allotted task. At the correct moment, they withdraw, and the procession starts again, only to stop in front of the next jig with its set of tools. And so on to the end of the line. Here, an operator removes the partly machined block and puts it on a gravity feed track, which takes it to the next machine. He then cleans the swarf from the fixture and returns it empty by a traveling conveyor to the head of the machine. At the next section, the block on its newly machined base is clamped into another fixture and rotated into position under a line of vertical boring tools. These tools wait till the fixture is accurately located and then descend to machine the cylinder bores. Once again, the block moves forward on roller tracks to yet another section. After a short journey, it is halted, located on dowels, and securely clamped in position. A gang of circular milling cutters descends and machines the crankshaft bearing faces. When that's done, the control board once more stops the operation. The block is lowered on the track and automatically ejected. Watch how the steel hands lift the cylinder block and pass it on its way. Once more, the panel flashes and clicks. The block is raised into position under a jig and securely held while several sets of drills descend onto it. And so these cycles of machining operations continue. In and out, the tool heads move, all controlled by the electrical panel, and all acting with a precision that can only be maintained by machinery of extreme accuracy. Again, at the end of the line, the block is taken off and transferred to yet another machine, watched over by the control desk whose winking eyes report progress. Should any operation go wrong, this panel stops the machine at once, and not only stops it, but shows unerringly where the trouble is. Watch how the blocks pass steadily along with the cutters to their machining station, never a halt, never a falter. At the correct point, the end block is released, while the others are securely held, and the large circular cutters return to machine the end face, the last operation on the block. After machining, the blocks are released from their fixtures and passed on a track to the end of the machine. Here, each block is fed sideways into a rotating box, which turns it completely over and ejects it onto a roller track, and then rotates back, ready to receive the following component. Thus, without human aid, the cylinder block is completely machined, drilled, bored, and passed to the assembly lines. Here is a similar device for machining cylinder block heads. Any component produced by these processes must be accurate, because any error in either tools or machining would be instantly located by means of the automatic gauges which are built into the equipment. Besides these gauges, patrol inspectors pass up and down, keeping a vigilant eye on all working parts so that production shall not be impeded. Masses of machine heads carrying gangs of tools advance and withdraw with the precision of guardsmen on parade. Uncanny in operation, their every movement is known and in fact controlled by the switchboard overlooking it. A glimpse of the gearbox section, where the operator in front of his switchboard loads gearbox cases into fixtures and sets them off on their journey. Watch the empty fixture moving into place in front of the operator, while unmachined components pass round, ready to be loaded into their fixtures. Once they are loaded, the electric mechanism comes into operation, and the machine heads all move into action. Pumps controlling the cutting fluid send out a flood of liquid, and the drills and boring bars move in. Here again is a clear demonstration of how these transfer machines work. The operator loads a gearbox extension into a fixture, and from then on, the machine takes over. Each operation brings the component a step nearer to completion. When all the various sequences have been gone through, the platen with the fixture and component is passed to one side. It is then lowered onto a moving track where it travels back under the body of the machine and reappears at the head in front of the operator, who extracts the finished component and then repeats the process. Finally, a machine for drilling crankshaft oil holes. These are at varying angles, and therefore the platens carrying the fixtures are made to rotate so as to bring the angular holes into line with the drills. These wonderful machines are a far cry from the rollers the Egyptians used, and yet in practice they are doing the same thing, lessening the load on man, easing his work, and at the same time increasing his productivity. This method of production has been called automation, and it is sometimes spoken of as though it was something new and something to be feared. The only new thing is the word automation. Actually, it is a name for a method of scientific production that has been developed through years of hard work embodying the highest engineering principles. Progress demands and can only succeed by better production methods. Automation is progressive production. In fact, it is the logical outcome of progress. In the vast British Motor Corporation plants, production is always keyed to progress. That's why the cars of this great corporation are always in the lead, and why they are all quality built.